Welcome to this series of introductory lessons related to the time value of money. My name is Brent Pritchard. I teach college finance courses, and I'm here to help you grasp this all-important concept. This introductory series is designed to help you learn how to apply the mathematics of finance in less than a month, provided you commit to one or more lessons a day. It's that easy. Acquiring the hard skill that is the mathematics of finance does not need to be hard. I hope you enjoy this fun new take on this age-old concept. And after you've done that, please consider telling your friends about this channel, TVM Rules, and the book, Would Your Boomerang Return, also known as the Boomerang Book, that made it possible. I like to start every class with a quote, so here we go with the quote of the lesson. Time is money. Time is money, and I want to thank you for spending your time, your most precious resource, watching these videos. If you want to learn the time value of money like the back of your hand, I can tell you one thing that is almost certain. As close to 100% as we can probably get. You are not going to learn how to apply the mathematics of finance using a traditional textbook. If you're lucky, you might find 2 chapters on the topic, but I digress. We're on the heels of what just might be the longest video in this introductory unit, and rightfully so, since manipulating the investment yield can cause some people's heads to spin. This lesson, on the other hand, just might be the shortest. Return on investment. This is what the true investment yield is. Now, it's important to recognize that interest, for example, is not always the only financing charge when it comes to debt or borrowing. There may be an origination fee or the like that leads to the effective cost being more than the stated or simple interest rate. From time to time, you'll need to use your financial calculator to solve for I, but that doesn't change the fact that it's still a true investment yield. In other words, a yield that is time value of money friendly and which can be used to discount or compound monies over time. Remember TVM rule number 1. It's a no-no to add or subtract or compare money in different points in time. In this lesson, the focus is on the difference between an annual and annualized yield or rate and how to move between the two. The key point of this lesson is that an annualized investment yield is a kind of simple, call it false investment yield that won't fly. It's not time value of money friendly. An investment yield is annualized through simple multiplication, as described on this slide, and we'll go through an example or two. Yield to maturity is a classic example of an annualized yield. We see this when we look at U.S. Treasury bonds, for example, that typically pay interest on a semi-annual basis. And if we wanted to think about it this way, we could say that the compounding period for a U.S. Treasury bond is semi-annual. In the last lesson, we worked the building block true investment yield equation backward. And we do a similar thing here in this lesson as we perform the opposite mathematical operation that it took to move a true investment yield to an annualized yield. So let's start with our first example. We'll just write this out using numbers and words. Let's say that you were provided with a yield to maturity of 4.1554%. The decimal form is 0.041554. So we already mentioned that U.S. Treasury bonds typically pay interest on a semi-annual basis. So the starting point for this yield to maturity, which is nothing more than an annualized yield, would have been the true semi-annual yield. Well, how do we move a true semi-annual investment yield to an annualized yield? How many semi-annual periods are in a year? 2. So we multiply by 2, and then we get 4.1554%. Here's what I was talking about when I referred to the opposite mathematical operation. We multiplied by 2 to get to an annualized yield. So to determine the true semi-annual investment yield, we simply divide by 2. And when we divide by 2, we get 0.020777. That is the true, fill in the blank, semi-annual investment yield. Here's a real-world example that we're going to be working through. And as I was writing this question or example, I thought about amortization. Maybe that's a new word for you. If it is new, it simply means to pay down. So this mortgage loan over its 240-month term would fully amortize or pay down. Most mortgage loans require simple accrued interest, if you don't know that already. So the way that we can think about this asset, yes, it's an asset from a lender's perspective. We can think about this asset as having a monthly compounding period. It's important to point out that this mortgage loan in this example does not contemplate additional financing charges or fees beyond interest. So let's get about drawing the TVM wallet. Doesn't need to be pretty. Although this is kind of looking pretty, I'm going to write in the 5 primary TVM variables or inputs, the ones you'll be using most often probably. In the first window of the TVM wallet, we visualize. And we've got a 240-month loan, negative $350K at time period 0. You may be wondering, why are you putting a negative sign in front of $350,000? Well, blame it on my working 22 years to the day in the commercial real estate industry as a commercial mortgage lender. A loan, as we discussed, can be an asset from, and it is an asset from the lender's perspective. How do we interpret the negative sign here? Those $350,000 would be invested. The lender would invest them. $300,000 would leave the lender's quote-unquote hands. Now, if you wanted to, and if you wanted to look at this from the borrower's perspective, then there would be a positive no sign value associated with PV because those monies would be coming into the borrower's hands. The negative sign in that case would be associated with the PMT payment, but we're not going to do it that way because it's hard to teach an old dog new tricks. And so I'm going to work it like I normally do. FV has a 0 value here. Why? Because this mortgage loan would fully amortize over the 240-month loan term. We're trying to determine the PMT payment. This is an even payment. This is a level payment, also referred to as a fixed payment. Hint, 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 this is an annuity. So we're solving for an annuity here. How are we telling time on this timeline? Let's fill in the blank. There's a monthly time span in between period markers on this timeline. So in the subscript, we're going to put in M. That's going to remind us that 240, that means months. There are 240 months in this investment period. We need to solve for the true monthly investment yield because only a true monthly investment yield will fly. Now, we were provided with the simple annual or annualized rate of 3.65%. In decimal form, that's 0.0365. We were told that there are no additional financing charges for this mortgage loan in this example, and so the starting point was the true monthly investment yield. How do we get from a true monthly investment yield to an annualized investment yield? We multiply by 12. Multiply by 12. Here we go through the opposite mathematical operation. So to determine the true monthly investment yield, we're going to simply divide by 12. And when we do that, we get 0.00342. Now, my trusty HB12C requires that I input the percentage format. So that's what I'm going to do right here. The TVM wallet, as you may have picked up, is used in conjunction with a financial calculator. So hopefully you have your financial calculator at home and you're plugging along and you're working the math. When we work it out, we solve for the PMT payment. And the PMT payment, and I call it PMT payment because it's an even or level annuity, is $2,057.01. We don't want to forget about the penny. Let's double check our work like we do. I mentioned that this is an annuity. Present value of an ordinary annuity, that's the building block time value of money equation that we're going to be using. And here's the equation. It's always good to double check our math. 1 plus I, that's the true monthly investment yield in this example. 1 plus I raised to the power of n, that's uppercase N, times I. Okay, most mortgage loans require that interest is paid in arrears. That means that the interest that's due on, let's say, the first of the month is a result of the principal loan balance that was outstanding during the prior month. So we've got our present value of an ordinary annuity. That's the $350,000. Now I want to point out that there's no negative sign associated with this $350K. Why? Because notice the negative sign in the numerator within square brackets. There are negative signs in the building block time value of money equations, but you won't find a negative sign associated with a PV, an FV, or a PMT payment. So these values, or those values, carry a positive no sign value. We're solving for the payment. Let's make sure we have enough space here. 1 plus 0, 0, 3, 0, 4, 2. We raise that to the power of 240. Now the way I teach the time value of money, there's a relationship between uppercase N and PMT payment whenever you're dealing with an annuity. The same thing down here in the denominator. 1.003042 raised to the power of 240. And here we multiply by I. 0.003042. So let's work this down. $350,000 equals the payment. All these numbers in the square brackets, they work out to 170.149656. And when we use algebra to rearrange, we can solve for the payment. The payment equals $350,000 over this longer number, 170.149656. So the payment equals, you ready for this? $2,057.01. We're going to circle that. There's our payment. That's good because that's the answer that we found working this through the TVM wallet. So that's a wrap. If you like what you learned in this lesson, please consider telling your friends about this channel, TVM Rules, and the book that made it possible. There's a difference between the true investment yield, which is represented by lowercase I, and the simple investment yield, which doesn't consider the effects of compounding. One is time value of money friendly, the other isn't. And an annualized yield or rate is a glorified, simple, call it false, investment yield. If you haven't purchased your copy yet, all the important information on this all-important topic is gift-wrapped within the cover of Would Your Boomerang Return. Until next time, enjoy the gift that is the present.